Hello, and welcome to Aggressive Physics. Today is day 96, and what I'd like to talk about today is dispersion. Now, if you remember, we have a chart for the index of refraction values in our reference table, and those are all listed for yellow light, frequency of 5.09 times 10 to the 14 hertz. Well, that's because different colors of light travel at different speeds in certain materials, and that's what we call dispersion. So dispersion is the separation of polychromatic light into its component colors. It's why a prism works. We take white light and enter it into a prism, and it separates it into its component colors, which, if it's white light, all the different colors of the visible spectrum. Now, the reason that's the case is because electromagnetic waves travel at different speeds in plastic or glass, and prisms are typically made of those materials. Those are called dispersive materials. So you have some materials where all light travels at the same speed, for example, air or the vacuum of space, and then we have dispersive materials where light travels at different speeds. If you have a dispersive material such as glass or water or plastic, you could actually break apart the light into its component colors. So a prism works by that process. White light comes in, and the red light will travel at a different index of refraction than the yellow light, than the green, than the blue, than the violet, and they all turn at different amounts. Because they turn differently, when they leave the prism, they're going to form a rainbow. Now, notice, rainbows are formed in the sky as well. And I just said that air is a non-dispersive material. So how do rainbows work in the real world? Well, if you remember, anytime a rainbow occurs, it's always after a rainstorm. So what happens is you have the rain that falls from the sky, and after it's falling, there could be still some water vapor and water droplets in the air. As the sun hits those, the sunlight, which is all the different frequencies of light, are going to disperse. As they disperse, they're going to form a rainbow in the sky. Now, you will notice, though, that the rainbow is only a certain shape. It's always what we see as a semicircular shape. The reason that's the case is because of the critical angle. Some of the light isn't escaping the water. In fact, it's staying trapped in and bouncing back into the sky towards the sun or other places into the atmosphere. So only the light that's reaching us is going to work. And since the critical angle of water is around 41 degrees, what we're going to see is that rainbows always have an angle of about 41 degrees. If we put our arm up and use the protractor to measure it, you should find that the value is about 41. Now, a rainbow does not actually have an end. It stops at the horizon because it can't continue. But a true rainbow would be circular. If you were to see a rainbow in an airplane or a helicopter, you would see that it has a full circular pattern. So what you can do is actually determine the fact that the index of refraction is different for different materials. In fact, I have a chart for fused quartz, and that's going to show how the index of refraction decreases as we increase the wavelength. So in this case, violet, which is around 400 nanometers, is going to have an index of refraction value of around 1.47. On the other hand, red, which is around 700 nanometers, is going to have a value around 1.455. Although those values are very close, it's enough to cause the different colors of light to turn differently and produce the rainbow. So a true rainbow outside is going to be a product of both dispersion, because water has different index of refractions for the different colors of light, and the shape is caused because of the critical angle. Anything outside the critical angle is going to enter your eyes. Anything greater than that is going to be trapped inside the water and escape into the atmosphere. So the fact that we have dispersion is why we have rainbows and why we're able to take light and break it into its component colors. So right now, that's it for today. A very short lesson, but dispersion is why rainbows work. And if you can find a Pink Floyd album that shows the prism, you'll see that the white light goes in and all the colors of the rainbow exit the other side of the prism because of dispersion. So Pink Floyd's a very big believer of physics principles, and well, they showed it on one of their album covers. So that shows how important they think physics is. That's it for today. Tomorrow we'll talk about diffraction. Thank you. Now, dispersion is the separation of white light into its components. And what we have is a situation where light doesn't always travel at the same speed inside different materials. In fact, a piece of plastic or glass is what we call a dispersive medium, which means different frequencies travel at different speeds. And that's why on the reference table, you'll notice that the N values are for a specific frequency. Now that means that as the light travels in here, when it hits, the red is going to travel at a different speed than the orange, then the yellow, then the green, then the blue, and when it comes out over here, you're going to get a rainbow. So a prism works with white light coming in, and because the prism is made of plastic or glass, which is the dispersive medium, each of the different frequencies will turn differently because N is unique for each. So the red turns a little less than the yellow, which turns less than the blue, which turns less than the violet. Now that's also why we have rainbows, because water is also a dispersive medium. So you can see the white light separated into its components as the water droplets in the air after rain are hit with light from the sun. So as they reflect backwards, you're going to be able to see the different colors because they're traveling at different speeds inside the water droplets. You'll also notice the shape of the rainbow is due to the critical angle. You're only going to see an angle of around 41 degrees because if you remember, critical angle for water was 48.7, I think it was, degrees. So anything that is greater than that is going to be trapped inside, and anything less than that is going to escape. So you're able to see the rainbow at about an angle of 49 degrees from where you're looking. So that's why it always has that same shape, that parabolic shape. So dispersion is when we separate light into its components. A laser will never be able to be dispersed because it is a single light. It's only red. So if we try to shine it through a prism, we're only going to get red light. We're not going to get the separation of the different colors because there aren't more than one color. So you need to have white light in order to separate into its components. So that's dispersion.